Hi everyone, I'm Mrs. Arnold Harsley and welcome to the Magic of Mathematics. Today we're going to be looking at algebra basics and in particular the language of algebra. So we'll look at what is a term, what is a variable, what is a pronumeral, what is a coefficient, what is a constant, what is an expression, what is an equation, and what is the difference between an expression and an equation. So first, what is a term? So a term can be a single number or a single letter representing an unknown value or a combination of both. Each term is separated by either the addition sign or the subtraction sign. So if we look at the examples, there's an addition sign in the first example. It's separating 5 and 9. And it says a term can be a single number separated by the addition sign. So 5 is a term and 9 is a term. So in 5 plus 9, there are two terms. In the next example, we've got the addition sign in the middle again, and then we've got the letter A on one side and the number 7 on the other. So it says a term can be a single number, so 7 is a term. It says or a single letter, so A is a term, and it's separated by the addition sign. So A is a term and 7 is a term. Therefore, there are two terms in A plus 7. For the next example, we've got the subtraction sign in the middle. It said each term can be separated by the subtraction sign too. And either side of that, we have 2x and we have 8. So we know that a single number on its own is a term. But what about 2x? Well, that is also a term because it says a single letter and unknown value or a combination of both. So 2x is a combination of a single letter and an unknown value. So in this, 2x subtract 8, 2x is a term, 8 is a term, so there are two terms here. And in the last example, you have the addition sign and you have the subtraction sign. So it says each term is separated by addition or subtraction. So what do we have here separating it? We've got 18c, we've got 2d, and we've got 9. 18c is a term, it's a combination of number and letter. 2d is a term, it's a combination of number and letter. And 9 is a term. So in 18c, add 2d, subtract 9, there are three terms. Okay, what is a variable? So a variable is any letter of the alphabet that is used in maths to represent an unknown value. So any letter of the alphabet means it can be A, B, C, D, E, F, G, all the way through to Z. The value can vary, which is why it's called a variable. So in this first example, we've got 4 plus A, but we don't know what the value of A is. It can be 1, it can be 2, it can be 50, 1,000, 5 million, any numbers in between. It can be a fraction, it can be a decimal number, but until we know what A is, it's just A. We can't evaluate or solve that unless we know what A is. The same with the second example. We've got 10 subtract B. B is the variable. It can be any value, and we don't know what it is. So 10 subtract B. What is a pronumeral? Well, a pronumeral is exactly the same thing as a variable. It's just another word for it. So some teachers, when they're teaching you, might call it a variable. Others might call it a pronumeral. When you're looking on the internet or completing online work, some sites might refer to it as a pronumeral, others as a variable, and there are differences between one textbook and the next two. All you need to know is it doesn't matter whether one teacher says it's a pronumeral and another one a variable. Just remember they're talking about exactly the same thing, which is any letter of the alphabet from A through to Z that is used to represent an unknown value. So what is a coefficient? A coefficient is the number being multiplied by a pronumeral or variable. So I'm going to go into multiplication more when I do the video about multiplying and dividing algebraic terms. But just as an example, if we look at 3x there, 3x means there is an invisible multiplication sign in there. So 3x is actually 3 multiplied by x. So that's what it means when it says a coefficient is the number being multiplied by a pronumeral. So you've got 3 and it's being multiplied by the pronumeral. Another way of saying it is when there is a pronumeral such as x here and there is a number that sits behind it or next to it. So in the first example, the coefficient of x is 3. In the example of 5 subtract 2x, we can see that the pronumeral is x and the number sitting behind it is 2. But because we're subtracting, you have to remember to take that with it, the subtraction sign with it. So in this example, the coefficient of x is actually -2. In the third example, if you've got x over 2, first of all, we need to look at x on its own. If you had x on its own, what would the coefficient be? Well, you've only got one x there. There's only one of them. So actually, when you have x on its own, or any letter of the alphabet on its own, the coefficient is 1. So 1x is the same as x on its own. You will never see 1x written in any algebra because x on its own is 1x. So if we go back to this fraction, that x on its own is the same as 1x over 2. Therefore, the coefficient of that x is actually a half. I'm just going to erase this to give me a bit more room whilst we look at the last example. Now you've got -3b over 8. Well, I'm going to take the -3 away just for a minute and have a look at b over 8. If you were asked to find the coefficient of b over 8, you would do it in the same way that you've just done this one here, x over 2. So b on its own is the same as 1b. So if you had b over 8, the coefficient of b over 8 would be 1 over 8. But we don't have b over 8, we've got -3b over 8. So the coefficient is actually -3 over 8. So what is a constant? A constant term is a number only, so there's no variables or pronumerals. Its value never changes. Its value stays the same. It's constant. The important thing you need to remember is this. The sign behind the constant or next to the constant must be included. So in the first example here, we've got 3x add 6. So it says here the constant is a number only, so the constant is 6, but you need to make sure that it's positive 6. But when you're being asked what is the constant of 3x plus 6, you don't need to write positive 6, you just write 6 on its own because we know already that that is positive 6. In this next example here, 2x add 5y subtract 8. 8 is the number on its own, but it says here the sign behind the constant must be included, which is the subtraction sign. So the constant of 2x add 5y subtract 8 is -8. In the final example, we've got 2a add 18 subtract 2b. Now you can see there isn't a number on its own on the end this time. It is in the middle. And you need to include the sign with it. So you know it's a positive number. So the constant for 2a add 18 subtract 2b is 18, We know it's a positive. We don't have to put the positive sign there because 18 on its own we already know is a positive number. So what is an expression? An expression is a mathematical statement combining one term or a group of terms, usually separated by the addition or subtraction signs. And we've seen some of that in our previous examples. An expression is one or a group of terms and may include variables, constants, operators, and grouping symbols. So an example might be 2a plus 4b subtract 9. So this is an expression. This is a mathematical statement. So it says one term or a group of terms. Well, we know that there's more than one term here because there's your addition sign, there's your subtraction sign. So we know that this is a term, this is a term, and this is a term. So there's 3 terms in that expression, in that mathematical statement. It also says we can use variables. So we've got variables here and here. There's 2 variables. It says you can have constants. The constant here is -9. Remember to take the subtraction sign with it. And also coefficients. So you have 2 coefficients there. You've got the 2 sits behind the A and the 4 which sits behind the B. So now we're going to look at labelling an expression, which is something you may be asked to do in your class. So this expression is 3e add 7f add 9g subtract 10. So first of all, I can see that there is 2 addition signs and a subtraction sign, and I already know that the terms will be separated by those signs. So I know that 3e is a term. So that's term 1. I know that 7f is term 2. 9g is term 3. 10 is term 4. So there's 4 terms in that expression. Now I'm going to label the variables or pronumerals. I'll use blue for that. So remember, your pronumerals or variables are represented by letters because we don't know what the value is. So E is a pronumeral, F is a pronumeral, and G is a pronumeral. So you can label it pronumeral. It would help if I could spell. Pronumeral, or you can call it a variable. So coefficients. The coefficients are the numbers that sit behind the variables. We've got 3, we've got 7, we've got 9. Coefficients. Remember, if you had just, for example, plus g, the coefficient of g would be 1. Remember, we have covered that, but that was as a reminder. All right, and then we've got the constant. So the constant is -10. Remember to take the sign with it. Constant. And altogether, that makes up an expression. So what is an equation? So an equation are 2 expressions that are equal, as shown by the equal sign. So if you have 5 plus 2, you've always thought the equal sign means, and the answer is 7. But it actually means that the value of 7 is the same as the value of 5 plus 2. It's like scales, they balance, and we'll look at that on the next slide. So here's a picture of the balance scales, and you can see at the bottom there's the equal sign. It's telling you it means is the same as. So using this as an example, 4 plus 2, which is on this side of the balance scales, is the same as 5 plus 1. And if we solve both of those, 4 plus 2, of course, is 6, and 5 plus 1 is 6. Looking at this example, you can see the equal sign would be here. So if I put that over there, if you just count what's on this side, you can see it's balanced. So whatever is on this side is the same as what's on this side. So on this side, we've got 1, 2, 3, 4, 5, 6, 7 red dots. On this side, we have 3 red dots, and we've also got an X. So first of all, there's a couple of ways of working this out. It is a simple equation. You can say what plus 3 equals 7, or you can say, okay, well, if I take those 3 away, just to leave me with that X on its own, to balance the scales and make them the same on both sides, I've got to take 3 away from that side too. And that, of course, leaves you with 4 dots there. So X is 4. If you substitute that 4 into the equation where X is, you've got 4 plus 3, which of course equals 7. So what is the difference between an expression and an equation? The easy way to remember it is that expressions do not have an equal sign, equations do have an equal sign. So an example of an expression might be 2a plus 4b subtract 9. An equation might be 5 plus 1 equals 6. An expression can become an equation if the value of the variable is known. So for example, again, if we've got b plus 9, that's an expression with 2 terms separated by the addition sign. If you're then told that b equals 3, then b plus 9 equals what? You substitute the 3 into where the b is, so you've got 3 plus 9, and then it equals 12. So that's how you turn an expression into an equation when you know the value of the variable. So today, what did we look at? We looked at the basics and the language of algebra. We learned that a term is a single number, so it can be 5, it can be 15, it can be any number. A single letter, such as A or X, or a combination, such as 2A. Separated, it can be separated by an addition or subtraction sign. So we've got A plus 5 minus 15B. We learnt that a coefficient is the number that sits behind the pronumeral. So there's the pronumeral, the coefficient of that one is 2. And that a pronumeral and a variable are one and the same thing, which is a letter of the alphabet that's used to represent an unknown value. The constant is the value that never changes. So if we use this one here, the constant there is positive 5, which is written as 5 on its own. An expression is a collection of terms separated by addition and subtraction signs. There's no equal sign. So 5a plus 2b minus 9. An equation has an equal sign. Equa. So 3 plus 5 equals 8. Or you could have, as in my previous example, 3 plus a equals what? And then you're told a equals 5. And my pen's not working. There we go. Okay, so thank you for watching. If you found this clip useful, please subscribe to my channel, Jane Arnold Harsley, all about the magic of mathematics, and leave feedback about what you liked or what can be improved. So until next time, see ya. There's the balance scales, and it tells you here the equation sign means is the same as. So it's telling you that 4 plus 2 is the same as 5 plus 1.